Hurry up, hurry up. What's the first thing we do? So does it make sense? Is it the same as what we have learned just now? Okay, remember what we say? What is your K? Very good. So what does it mean? Here, do you draw it like this or do you draw it as a string?
String.
Okay, because it's the same FEA over L. Right. You have 5 minutes. Draw. I guess someone needs to draw. Yep.
The force, is it halfway through only or is it the whole thing?
Very good question. This force, does it go all the way through? Correct? It only, that's a very good question. But imagine this is how to say? Like you, that is why I want you to try this because in the exam that's how they will do it. They will give you a very complicated type of physical geometry, then ask you to do it like the way that you are. You know how just now what we do here, you know. So the force will only apply where? At the node. The force, just like the displacement, will only be applied at the node. Okay, I'll only apply at the node. Because that is my only degree of freedom. I can't apply it anywhere else. Because I do not know what is the displacement. I will only apply it at the degree of freedom. How many nodes are there in this 1, 2, 3, 4, 5. Okay? Okay? This is where you all think, I tell you what, exam come will give you some weird geometry, you'll be stunned. So you all better try it now. Okay? Actually, once you can translate this into this, half the battle is won. That's why the drawing is always the most important. The drawing is always the most important. Once you get into something like this, most of you can get it for sure. How to translate this into this? That's the question mark.
So force point.
Five minutes. Yeah, 2 more minutes, You all still need this? Imagine next week at this time, we are not going to do any of these things. We'll be talking about abacus already. So you all better take tomorrow to know how to do all these things. Okay? Next week, this time, promise will not be doing this. I will assume you already fully grasp this already.
Lihat, gua sekarang sepatu sejauh itu dia bungci loh.
6 feet 24. Oh my exactly very here.
Ini kan highlight.
Students, make sure you finish up. Thank you.
So sir, does that mean that F3 and F4 will be zero?
Very, very good question. Think about it. Wait. Think about it. Just now we said how many nodes are there in this model? 5. That means how many U will you have there?
5.
How many F will you have there?
5.
Exactly. Each node will have, because we're doing only translation, we will only have 1 degree of freedom and 1 force, 1 external force. Okay? That's a very, very good question. Even though we don't apply it, so what is F3 per se?
F3
equals to?
F.
Equals to? F3 equals to what?
0.
F4?
0.
0.
Hey, ask who to draw. Draw. Yes, you are doing that.
So F1 also is used.
Draw and write. They already just do.
And so is that zero.
Do the same thing. Hey, y'all must be quick, seriously. Like that, y'all, next week, we go to something else, then y'all don't have enough time to try. I can tell you, you're going to have problem. So y'all must really work fast. Next week, imagine this time, look at Abacus, how to do your model, how to do your machine, how to impose the boundary condition. Totally different thing. Right, I say already.
So we
Will be that mark for sure.
pause.
You also need this. You also need this. Hey, you all need to take picture, whatever, please do. Next week, we will not come back to this after 5:30.
一样。我跟你讲是这样自己打的。我给你可以有自己要想要那个什么不懂台湾人。这个那是台湾台湾谁呢？啊？台那三年台是用手写 Excel 方。Excel 哇
Screenshot. I saw a screenshot. Onwards.
Do your individual statement maybe today. I think actually this is quite simple. So we are going to do both questions before we go off. Okay?
So for assignment 1, right? You need to do inside Excel. And
Don't need. I show you later. What the past year did. I just show you last time, right?
words.
Huh?
Inside the words.
No.
PDF.
You just you just scan it lah.
You just draw? Print out and draw. 更简单。我们用手写了。
Wait ah. Like this. Don't need to. Okay, wait. Don't need to type it out. Okay, this is a bad example to do. Yeah. I really don't need the like this. Yeah, correct. Okay. Then you do your own inverse. You see, I don't care one. This one number. I just check this one. Okay, so whatever you all do here, you all better do in Excel. This can only be done in Excel, honestly. You can't do it by hand. Okay, 3x3 matrix, 4x4 matrix. In the exam, you're going to do it by hand. No way. 2x2 matrix is the maximum you do. Manually. Okay. Then you see, hello. Wait. Look here. Okay. All have what? Look here. You need sign notation. Okay. All will have. In your engineering document, if you don't have all these things, this is just a string of numbers. Totally, absolutely nothing at all. Most of the time, this is where you can see the problem. People forget about the sign notation, people forget about the units.
Okay.
Yeah, I mean in the actual engineering application, that's why you see a lot of
Do we have to attach the Excel
Sorry?
file?
Huh?
Do we have to attach the Excel file?
Don't need. Hey class, listen hello. Don't need to attach the Excel file. Don't attach the Excel file. Same in assignment, same in your exam. You do your own Excel, you come out with it in the exam, you take a picture, scan it, send it to me. Of course there is an attachment now. This one you attach in the canvas. Question. I can't mark whatever I can't see. Okay? So you want to scan, better do a good job. I have people that come up with no resolution. Same problem. If I was to send this to RMIT, they were not going to see it. How can I award mark for that? You know what I'm trying to say? So you all want to scan, do it properly. I'm sure you all can do a proper job of taking photo, right? So make sure you take properly, yeah? Exam also got time, because 3.5 hours. Sorry? You should be virtual if it's not wrong.
Virtual.
For your exam, this one. Last 2 years, virtual. I'm not sure. I'm not sure. Okay, but last 2 years, COVID is virtual. Okay, what was the wrong?
Exam.
I say go to Excel, but you do not need to send me your Excel table. You know what I mean? This is like I said, this is hello, this is engineer and we do it like how you do your everyday job, you know what I say? Hey, hello, are you all done? Can we take a look at this?
Repeat course.
Wait, let's just go through this. So you see, look at this. Okay, never mind. Yours, tomorrow, next week, I expect you to finish question 1 to 3. Okay? Next week, when we come back, I'll spend half a lesson to do 4, 5, 6. Okay? It's not going to be easy. After that, you all will see 4, 5, 6 is not going to be easy. That's only half a lesson. I can't afford to go back to cycle back to question 1 to 3. Okay? Do you all need any help? Do you all need any clarification for this? Can you all, let's put it into the big matrix. So after this, what do you all do? I assemble them, correct? Which is easy, because all this is in linear, correct? Sorry, not all this linear, all this is the series. Okay, where is that?
The table.
All this is in the series, okay, so it's easy. Okay, so it will be what? It will be K1, negative K1, negative K1, K1 plus K2, 0. As I'm assembling the global matrix, okay? 0, 0, 0, U1, U2, U3, U4, U5, correct? Equals to F1, F2, F3, 5. Right? Negative K2, negative K2, K2. Then I add in the third matrix, which is plus K3, correct? Minus K3, minus K3, K3. Plus K4 minus K4 minus K4 plus K4. Anybody don't agree? Hello, hello, hello. Can?
Yes.
Now, what are we going to solve?
3 by 3.
Very good. First, very good. I'm solving the 3 by 3 matrix. This is equal to 0. This is equal to 0, correct? So I'm taking out this and this and this and this. Correct?
Right.
Okay? Do I take out? Okay. After that, what else can I do to simplify this? So I'm taking out this, correct? I'm taking out this, I'm taking out this, correct? So what is F2? Equals to n times 200. Agree? What's F3? Huh? F3 equals to?
0.
F4? Do I take out the third and the fourth row? No. Why? Why? Hurry up. Somebody else say something. Quickly. Sorry? Very good. Very good. Okay? Because U3, U4 not equal to 0. That's why we can't remove them. Agree? So it's a 3 by 3 matrix. Okay? Understand? After that we solve. So from this we solve for U2, U3, U4. Correct? Read the question. What are we looking for? First is the node displacement, followed by. So how do you find what is your element stress? So this here, just now the first question only have one part, find the stress. The two parts, find the displacement and the force, spring force, correct? Which we say previously, right? You know just now we say the spring force equals to what? F1, F2, F3, F4, correct? So this is the first thing we do already. There's three parts to this question. Second part, how do you find what is your spring force? Before that, okay, F equals to, let's say F1 equals to what?
F1 equals to K1.
U2 minus U1 K1. Okay? Hey, just now this one never denote the U2. Okay, you must denote this. Okay? So this is the force, spring force, as per the first question. How do you know what is your stress?
You mean the second one?
No, after you have done your spring force already, right? How do you know what is your stress? So the stress equals to what? Just now you say the answer already, is A over L, correct? So your stress, sigma 1, right? Okay? Is equals to F1 divided by A1. Correct? Do anybody do understand this? Huh? This is stress, your stress. Sigma 1. What is your Young modulus? Recap. I'm not going to accept if you tell me you don't understand this, you don't know about this before that. Your Young modulus, right, equals to what? Your stress, sigma, divided by your strain, epsilon. Does it ring a bell? Yes? Correct? Who don't know about this? Okay, so it's the same thing. This is not a elementary course. So you're supposed to already know some of these things already, okay? Okay, so sigma 1 equals to F1 divided by A1. Okay? Okay? Some people do it otherwise, which is also okay. Because just now I say, correct? E equals to sigma divided by epsilon, correct? Some people do it the other way, which I'm fine, okay? The other way to do it is, you know what is my E, I know what is my epsilon. Epsilon is what? Is my deflection, which is U1 minus, U2 minus U1 divided by L. Also can. This is your epsilon, correct? This is your epsilon. Correct? So you want to do it this way, mathematically it will be exactly the same. Fine. Okay? What else are we missing? There's one more thing we're missing. What's the third thing? Hey class, what is the third thing we need in this question? What is it asking for? Hurry up, hurry up.
Support reaction.
Support reaction. So what is the support reaction?
The two sides.
Correct. Just now we say that is your F1.
F1 and
F1, a capital F1 and
F5.
F5. And we say that just now, but actually it's up to you lah. I will normally put this as R2, R1. Okay? So how do you know what is your R2 and R1? Huh?
Not zero.
R1 equals R2.
Sorry? R1 is not equals to R2. Wait. Never mind. Wait first. What is R1 and R2? I say just now we cancel this out. It's not because F1 and F5 is 0. It's because U1 and U5 is 0. It's not because R1 and R5 is 0. R1 and R5 confirm you have something because there is a reaction force there. The fact that you restrain it, then you can have a 0 displacement. But the fact that you have 0 displacement, for sure there will be a reaction force. Agree? Remember, we go back to our original. Line element. Look at this line element here. One line we learned today what? For U1, okay? If I have a spring, okay, I impose a U1 displacement at node 1. Correct? What is the force I need? I need the F1 equals to K1 multiplied by U1. Agree? In order, let's say you have a spring here, I fix this, I push it. For you to have a displacement of U1, what is the force I need to apply? U1 times K1, correct? What is the reaction force?
Negative.
Negative U1 times K1. Exactly. In order for me to have this force, it must be the opposite and equal force. Agree? So for sure, there will be a force there. But F1 and F5 is not going to be the same. Okay, they will be definitely different. But just as here, this force, the summation of the reaction force, will be the same as your external force. Agree? The summation of your reaction force will be the same as your external body force. Okay? So how do you do that? How do you determine the reaction force there? Huh? It's not so complicated. But I just told you all just like 2 minutes ago. There. What line element do I?
Is it what summation, then summation of all forces, then negative is?
You can do that. Actually, you can do that. That's how abacus will do it. But in our case, we cannot do that like that. So what you will do is you find same thing as what we have here. I have my displacement here. Assuming this is fixed, correct? I do it back here. The displacement of this U2 minus U1 that's okay will be your reaction force. Right.
So it's R1 equals to K1 U1 minus U2.
Correct. Okay? So your R1 equals to what? U2. Do we need minus U1? Why?
Zero.
Okay?
U1 minus U2.
Okay? Can? That's it. Last question. Then we are done for the day. You want to see this?
Because here you find the second one.
Just in this, just in this. Only I. Let's do the last one. Can we just focus on the last one? Hey, hello. We have 10 minutes. How much you want to do for question 2? How much you want to do question 2? Draw. Class. How are you going to draw this? How are you going to draw this? This is actually a very good example. I deliberately skip this first because I want to see this first. Then you can go and do this. Okay? How are you going to draw this? Very good.
Another string.
Yes, agree. Very good. Okay. Wait. Sorry. Hey, class. Good point, typo. Okay? So this should be positive, and this should be negative. Good point. Okay? Why? This should be negative. So imagine if I have a positive here, right, the reaction force must be negative. Okay? Imagine I have a positive here, right? The reaction force will be positive. Makes sense? Okay? It should be. It makes sense. Yeah. So imagine I have a positive force, a positive displacement here, right? The reaction force will be what? If I have a positive force in this direction, what is the reaction force here? Also in this direction. Okay? Okay, hey class. Draw. Minimally, if you draw it, is half the better one. So I want everybody to at least draw this. This is going to be very fast. This is going to take 5 minutes.
Wait, so then you just now said it's the opposite of the force, right?
Yep.
Now it's descends to opposite.
Yeah, it is. The reaction force is opposite. What do you mean? This is coming in, right? So this reaction force will be the other way around. Yeah, that's why this one R2 will be negative. R2 will be negative.
Oh, because it's compression.
Sorry?
So the force is
Okay. Hey guys. The reaction force, the reaction force, think about it. Okay, we will come back to this next week. The reaction force, let's think about it. But can you all do this first? Hey, hello. Are you all doing a lot? I'm not going to come back to question 2 tomorrow, next week.
The picture, the diagram, right, says it's like compression from my understanding. We need to say, instead of first matrix, right, we should start off with negative.
Very good point. Hey guys, actually that's a very good point, but never mind. Later I will explain that. Doesn't matter. Okay? Hey, your good point was asked. Oh yeah, I think I must say. Okay, see, just now I say, correct? How many nodes is this in this model? 3 nodes, correct? U1, F1, F3 now is what? Negative. Okay, it's a negative negative N
Compression.
N times 10 kilonewton. Okay? When we go next week or when we go on the third week, all these kilonewton, newton, millimeter, meter become very important, and you will see why. So that's why this is all become very important. I want everybody to quickly draw, then we shall do the same thing, and this will cover the entire question. First and foremost, before I end, hello. Let's look at this. Read the question. Find for the spring and bar assembly. Determine what? How many things you need to find here? No, first, always find what? It's always a U. It's always no displacement. Okay? No displacement followed by force and the reaction. And so in your question, every time people don't read the question, okay? In this question, you must give me how many things? 4 things. Question 3, how many give me? 3 things. Correct? You don't have confirm data one. Okay? Confirm will become answer. That's why it's important for you to read. So everything you should already know. You know your spring force, you know your stress, correct? Displacement, reaction, everything you know. Sorry? No, but you know what I'm trying to say. So you denote the same diagram as per what we did just now. It doesn't change anything. It's only when your F3 comes in, right? It's a negative F3 now. But you do it exactly the same as just now. It's always left to right positive, left to right positive, doesn't matter. Okay? During abacus, I can show you this becomes very, very important. All these things become extremely important. Still same. Yeah. That's why it's important. At least this is what you see. That's why our denotation become important.
Half the metal wood.
我做那不会做。
Yeah, the indentation, I say the where is positive, the arrow to debug the positive.
K1, the same as K1, K2. You know, K1 plus K2. The same as the additional.
Just the direction is this way.
Same thing, imagine if this is the actual condition, you expect things to what? Imagine like push this right. This will what? This will flip up in real life, correct? This one you will see some sort of lateral torsional buckling, that type of thing going on. In this case, no, because we are only applying a single degree of freedom, which is tension or compression, so it will not flip up. So, but then that's why when it comes to your exam, then you need to still a little bit. The exam will only be translation. Confirm will not give you quotation, it's because you can cover it. So you just know that it's always translational type of spring. We're only doing translational type of spring here. Okay? Hey, you all copied out already. Let me find the assignment 3, then I show you all. I said I'll show you all, right? Oh, you also want to see? You all want to? Are you interested? The assignment is this year one is more complicated than assignment 3. Than what I'm going to show you.
What do I do? even 我是不可以，我做 second job 哦 ，correct， 我的直接砍掉。
可以来讲那个休闲讲解。你可以中国那里我人呢，原先是原先首先是去把它哦。
Hey class, see Hey, here you must put it as U1. Okay? So you must do this way. So if you are telling me that this node that can move in this direction is positive, okay? This node you must show me is move like this. U2. Okay? Can? Same thing here. This you must show me U3. You do not need to show me the force because the force and the displacement are correlated. Okay, just show me that one side, left to right, is positive. That's all you need to show. Okay. All same direction. So that's why I say the F3 is in the negative. So it cannot be, this force cannot be in the other direction. Okay, it must be like this. Okay. Okay. You know what's your F, right? You know what's your F? Correct. Here, back to here. F1, U1, is it 0? What is the matrix we are looking at here? Is it a 2 by 2 or 3 by 3? 3 by 3. it will be a 2 by 2 matrix because U1 is 0. Okay? And then tell you what, class, listen. Why it must, just now I keep on telling you all about the 3 by 3 matrix and all these things, how to walk 5 by 5, 3 by 3, right? But I want to let you understand one thing. The reason why it needs to be a 2 by 2 matrix, why? Because F1 is what? No, it's not 0. F1 is unknown. So even if you inverse, you can inverse a 3 by 3 matrix, but you do not know what is F1. You know what I'm trying to say? Do you know? Okay? F2 is what? F2 is 0. Very good. This is the external body force. How many external body force do you have here? 1. Okay? F3 equals to?
10 by 4. 10 to power 4.
Okay? So it must be a 2 by 2 matrix because F1 is an unknown. Okay? U1 equal to 0. Okay? So can you solve for this? You can solve by hand if you want to.
Solve by hand.
No need lah. Do Excel. Wait, let me see what else I have to say. Okay. So what's the 3 thing what's the 4 thing you need to do here? With this, you have solved number 1, your displacement. Correct? Number 2, what do you need to do?
Force.
Spring force, correct? So the spring force, same thing.
F1
This is your small f1, your small f2, correct? Small f1 equals to what?
K1 U2 minus U1.
K1
U2 minus
U2, correct? Okay, f2
K2 U3 minus U2.
okay? What else do you need to calculate?
The
Reaction. And last one? Stress. What's your stress?
FOA.
Huh?
F divided by A.
F? Correct. Yep. Very good. So it should be this A class C. Minus. Okay? Always balance. To be symmetrical, to be able to inverse, it must be symmetrical, right? Okay, take note. Okay? Yep. Okay, yeah, say. So number 3, what is after XN is just the short form for reaction. What is the reaction? Huh? Negative what?
Compression.
Where is F1?
K1 U.
Again, think again. What is reaction? I always say the reaction force is equals to the external body force.
Oh, is it the first spring plus second spring?
It is equals to your negative external body force. For sure.
No, but it's okay.
For sure. Negative F equal to negative F, for sure. Correct. External body force must be equal to internal body force. Just now is because we have 2. Now you have only 1. Agree? Yes? But it's a good thought, and you're don't get discouraged by me. This sort of thing, right, is part of the process for you all to think about it, which is actually very good. You also have to ask the question, what is this reaction, what is that reaction? It's for you all to think about it, okay, which is actually very good. Think about it some more. Okay? Hey, class. Wait, when I say, I'm not sure whether I better don't do it this way. Later, I got more problems. So it should be what? It should be negative F. You get what I mean, right? Because this is negative F, so it's a negative F. Agree? Agree, Because the force will be in which direction? Positive negative, the force is positive negative. If I exert a force in this direction, this force must be what? Must be moving left to right or right to left. Hey, hurry up. Moving to, if I have a force pushing it down, this pressure force must be what? Left to right. So it will be very good. I promise show you the assignment 3 last year one. Okay? This is last year. This year you all are doing the control. Okay? Stress concentration, all the operation. Last year, assignment 3 is just doing a hook. Push it up and stress here. Okay? Take a look. Okay. Okay, so they are doing this thing. So we need to do a plate model followed by a solid model. Okay? Plate model, so you can come up with a plate model. What is the stress here? I told you just now the second component is extremely important. This is the missile stress, this is the scalar stress. This is the S11, so this is the S in the X direction. Okay, if you see here, I push it up. Here will be compressive. Here will be positive. I will mark all this out, and you can see the explanation later. That's where it comes in. Okay, this is you get what I say. Imagine I push it up. Here will be what? Here will be compressive. Here will be what? Tensile, compression. Okay, all these things. That's why compression is important. Okay, S22. Look at this. S22 what? S22 is what? This is a stress in the vertical direction. Same thing here. When you have a rotational here will be one positive, here will be one negative. Alright? All these things I expect you to elaborate in your report, which is what done here. Okay? Okay, then you see all the stress that comes in, your plane stress, your plane strain. This is a shell model. Just now remember we said this could be represented what? As a beam, as a plate, or as a solid. Alright? So after that, they go on to do a solid model. Okay, a solid model with what? With refinement to the design. That's why I say this is important for you to learn your software on your own. After that, refine the design. How do I refine the design? I do a curved cantilever beam so I can save, so that I can increase material only when the cantilever moment increases. Okay, which you're going to see the conrod even more. Okay, refinement of the design. Then after that, cut through. Because why? Because I'm only interested in the bending stress in the thickness direction, correct? So actually I can remove some of the material here. Okay, so this course is going to be extremely applicational. Okay, actually by right they also we're supposed to come up with what? A hand proof for this. How do you know your software gives you the correct result? What you are doing today, prove by first principle. This cantilever moment, cantilever arm, force applied, bending stress here can be checked against your model. Okay, it's not just simple punching through the numbers. Alright? Okay, thank you everybody. That's all for you all.